Right, Edx M2 January 2011, question 8 on collisions. Here's the question. Pause the video and take a moment to read the question carefully, and let's get started. So, if you've read the question, you'll know what's going on. This particle's got a speed of 6 before it collides with the vertical wall, and the coefficient of restitution is a third, so we can easily write down that v equals 2 meters per second as it rebounds off the wall, 1/3 of 6. Now, the K lost, the question tells us that the K lost is 64 joules. Now the K after is a half m times 2 squared, a half m times 4, which is 2m, and the K before is a half m times 36, which is 18m. So the loss is m times 16, and we know that that's equal to 64 joules. So that gives us m is 4, as they want, as required. So that's fine. That's found m is 4 kilograms. Let's carry on then. The next part of the question, I've drawn the diagram already, talks about P colliding directly with the second particle Q. This is particle Q then, and this is particle P, which is just bounced off the wall. And we've got to show there'll be a second collision between P and the wall. Here's P then, and here's Q. In other words, we've got to show that the P and Q afterwards will be such that P is moving away from Q towards the wall, as shown in the diagram. So V1 greater than V2. Okay, so let's do this bit. As usual with these questions, we've got two things to use, two equations to use. Firstly, the principle of conservation of linear momentum gives us this equation. Just check where I get these terms from. I'm using the fact that we know m is 4 now, so instead of m, we're reading 4. So that's the principle of conservation of momentum. And we've also got Newton's experimental law, or the law of restitution, you may call it. And that says that v2 minus v1, or let's do v1 minus v2, let's do it in that order. v1 minus v2, which is the speeds of the relative speeds of P and Q after impact, is minus E into U1 minus U2. That's how I usually quote Newton's experimental law. The speeds afterwards, subtracted, is minus E times the speeds before impact, subtracted in the same order. It's a fairly safe way of applying the NEL. In this case then, it gives us V1 minus V2 is minus a third, be careful with the signs here, to minus 2 minus 3. So now we've got two equations. V1 minus V2 is 5/3, and 2V1 plus V2 equals minus 1. That's what they boil down to. The equations above boil down to just those two. And they're quite nice to solve, so yep, we'll get 3V1 equals 2/3, which gives V1 equals 2/9. So V1 is a speed of 2/9, and it's positive, so it's towards the wall. So that shows that P is going to collide again with the wall, because V1 is positive 2/9 towards the wall. And that's it. That's the end of that question. We just need to look at the method marks. So we've got, in the first part of that question, we've got a method mark and an accuracy mark for getting the speed of the ball off the wall correctly. We've got a method and an accuracy mark for the expression for k lost, or doing the k before and a after, k after basically, M1A1 there. And then by correctly evaluating the loss of kinetic energy and rearranging that to find M, there's an M1A1 there. So 6 marks in total for the first part of that question. And for the last bit, for this bit we've got M1A1 as usual for the method and for applying it correctly for the conservation of momentum, and likewise for Newton's experimental law. Then for solving the simultaneous equations, another method mark, an accuracy mark for V is 2/9, and for the statement that it's towards the wall, hence proving that there will be a second collision between P and the wall. Okay, thank you for listening. That's the final slide. Yep. Thanks for listening.